Hello everybody. Um, Welcome to this video. We're going to be talking about Arena, the simulation package. Recently, Arena has changed the version, and with that, the organization of the blocks that are used to build the models. So we're going to have to review all this organization so we can navigate better and faster. So let's start. So this is the new layout for the program. We still have the working area here at front, and the data will be presented in the bottom part. However, the organization in the tabs to the left is different, and now all the data definition comes together, which is I think a nice feature because we can just concentrate in entering the data and verifying the purposes without having to browsing around different tabs trying to figure out where the data is. Now we can have all the data in the same location. For the most part, that's a major change. So we can build models again starting from discrete processing. There are the changes, so let's build some initial samples. So the first block is to create entities, and after we create an entity, we can process the entity, and then we can expose the entity. And what this will do is the entities will be created, they will process, it will delay for a while, and then it will be disposed. This is the most simple model you can build in Arena, and just with a few clicks you already have a simulating model. Of course, the main idea would be to be able to represent some relevant process, so we need to modify the parameters inside these blocks in order to represent what we want to represent. So if we double click in the modules or blocks, we have these windows popping up with the information that we want. In the case of the create, we have the time between arrivals and the nature of the time between arrivals, which could be a random arrival, or based on a schedule, based on or a constant, or some other expression. These other expressions could include random variables or random time between arrivals. And depending on the nature of what you selected, there could be different parameters. In this case, for the exponential, you only need the mean, and that's a sufficient parameter to describe the complete distribution. And you can select the units that will occur. Of course, the simulation package will take care of the transformation of the units. So if you say about the time between arrivals is 1 hour between customers, that would be an average, and it would be, for purposes of the simulation, the same as if you select minutes and select 60. At the end of the day, the transformations needed to be done inside the package will be carried out as needed. And here you have the number of entities that arrive per event of arrival. So if you have lots that arrive on more than one entity at a time, this is the size of the lot. And the maximum number of arrivals is not predefined, so in this case it's just set up as infinite. And the first creation is immediately as soon as the clock of the simulation starts. The process is a little bit more complex and has more options, because you can have the delay, sys delay, or sys delay release of resources. Resources are really the what creates bottlenecks inside the simulation. So if you add, here I selected, we're going to do sys delay release of a particular resource, say resource number 1, and we're going to be using one resource of resource type 1. This could be, for instance, this resource could be machine type 1. And we're going to be using, as I said, one unit. We don't need two machines, we only need one machine. And that's the only resource we need. And we have a distribution. In this case, we're using a normal distribution, a triangular distribution, also expressed in terms of hours. And the minimum value possible for this triangular distribution is half an hour, the most likely 1 hour, and the maximum 1.5 hours. So we could have other distributions, say for instance normal, and it will adjust to the parameters that are needed for the normal distribution are the mean and the standard deviation, and you would have the windows, or the windows to enter the parameters. Let's get it back to triangular, and let's do just that, and okay. And the dispose is just the disposal, and we can track statistics of how many entities have gone through the dispose. So if we run it now, you will see that we have a queue that grows and decreases dynamically as the simulation estimates that the entities would have to wait for the resource. We can modify the image for the queue so we have a better idea of what's happening with the queue. Of course, this does not have to match any particular layout at this moment. All we're doing is counting the number of entities in the queue. And there you go. The simulation is working, and this is the most basic simulation you can have. That includes the use of a resource, and because entities have to wait for the resource to be available, then there is a queue. If you go to the data definition, you will see that you can see that we have a queue, which is the one that was created, and we also can check that we have a resource. The resource is machine 1 that we created, and we only have one machine 1. In other words, we have one. The count of number of resources named machine type 1 is only. We can increase that capacity in such a way that the entities do not have to wait for the machine to be available as much if we have, say, 2 of them. So if we have 2 of them, we can serve 2 customers at a time, or 2 entities at a time, and therefore the queue would be smaller. So if I run the simulation now, you will see that now, although sometimes the queue grows for a little while, it is not as it used to be when we only had one. So you can run these simulations considering these resources. You need to have a balance in terms of the utilization, because if the utilization exceeds the capacity, or in other words, the utilization is more than 100, then you will face that the system crashes. Say for instance, if the time between arrivals, instead of being one hour, we say that the time between arrivals is only well, now I have 2 resources. Let's say it's only 0.45 of an hour. Now the utilization will be over 100, and you will see how rapidly the number of entities grows. And since this is student version, more likely you have the student version. The moment that we reach 150 entities inside the system will stop working, and that could be an issue. So make sure that for purposes of this course, the number of the utilization of your resources has to be less than 100. Otherwise, it will crash. That didn't crash because I didn't let it run fast enough. Let me reduce the number of resources. I didn't run long enough, I'm sorry. Let me reduce the number of resources to 1. And again, you find that in the data definition tab. And we left the create with time between arrivals of 0.45 hours. And we run it. And pretty fast is going to stop working. There you go. So this is a typical error that you would find when you exceed 150 entities. And if you encounter it, somehow the entities are not flowing as fast as they should in order to avoid the problem. So this is your first video using Arena in the newest version. This version is, let me see if I can find the version here. I think it's version 16. Tools, view, file. Anyways, it's not that important. So I'll see you in the next video, I guess.